Good day all. Mustapha, this is SOLIU. So this is the presentation on the lesson learned from our SSC 811 research work assignments. The introduction part. Uh, the oil and gas industry relies on the pipeline as one of the means for hydrocarbon transportation because of its flexibility and ability to transport crude oil from a long distance from offshore to an onshore facility. So the failure in high pressure, high temperature environments pose a serious risk on this pipeline. So understanding failure mechanisms is critical for pipeline integrity. So in order to maintain a pipeline to perform its initial task that is designed for, so we need to understand the failure mechanism. It's very, very critical. So some of the key causes of failure in high pressure, high temperature environments, the major causes are the corrosion, mechanical damage, operational challenges, and material limitation. The corrosion, which can either be internal or external corrosion or stress corrosion cracking. So these are as a result of the interaction and reaction between the pipeline and the environment, and in the presence of oxygen, water, and other corrosive material like hydrogen sulfide, carbon dioxide that are present in our produced hydrocarbons. So other key causes of failure are the mechanical damage, which might be as a result of the external impact on the pipeline. Which can lead to a fatigue impact, creating an impact on the pipeline, and also structural failures. These are the mechanical damages. The operational challenges, which is basically the human error, maybe because of the loss of circulation as a result of improper planning of the flow assurance, the stock pipe, well control issues. So these are the operational challenges that can cause failure to pipeline. So loss of circulation, well control issues, maybe because of the hydrates, wax deposition, asphalting that can block the passage of the flow line. The material limitation, so maybe because inadequate material selection or as a result of cost, as a result of economic factor and the likes. So it's either the material or as a result of a lack of knowledge. So it's either the cost or the lack of knowledge. The cost might be, if it is cost, that means the material selected was not up to standard. But if it is a lack of knowledge, that is an improper selection of the materials. So some lessons learned, uh, advanced inspection techniques, which is the non-destructive test, real-time monitoring detect early failure. That is, to proactive detecting of any possible failure that can that can happen to the pipeline. So these are advanced inspection techniques. Material selection matters, that is proper selection of materials that are compatible. Material selection is a function of the nature of our produced fuel, the environmental factor like the operating pressure and temperature. Also, the predictive maintenance using artificial intelligence and machine learning to models and improve our failure predictions. We can model it and predict it for be like the next 5 years, the next 10 years, what can happen based on the environmental and the data we get from the sea, which is known as the bathymetric and other methods. So the compliance with regulations. So compliance with regulation, that is following the international standard for material selection and the design. So all this can also can prevent failure in the pipeline. So we need to analyze the failure. So because we can't really avoid it, but whenever it happens, it can serve as a lesson learned. So in order to serve as a lesson learned, we need to carry an analysis on the failure. So to do this, we need to collect the data. With the data collection, we gather some historical data, the environmental the environmental data, even the location data. So we need to gather all this data. Visual or microscopic examination, which is known as non-destructive test. So we visualize the failure part, we visualize the environment, the operating environment, and also we analyze all the failure part under the microscope. So we also do the chemical and mechanical testing to analyze the chemical composition of the material. Finally, we do the root cause analysis, which is the main to determine the fundamental where the failure emanates from. So in conclusion, high pressure, high temperature pipeline failures can be mitigated. You can combat it through proactive measure. If you have a proper planning, so we can mitigate the pipeline failures. Technological and data analytics are key in preventing failures. So that is the using technology and data like artificial intelligence, machine learning, and the likes. You can use all those technologies to prevent failures. Continuous research, improvement in our learnings, can use that. It's very, very essential. It's very, very key for safer offshore operations. So that is all from my hand. Thank you for listening.